And then, yeah, so now, so this is RStudio. So what I want to spend most of the time here is kind of going through some interactive examples of code, and so one of the things that's really nice about RStudio is that it has these things called R Markdown documents, and so if you've sort of been around GitHub, then you're sort of familiar with Markdown documents. But what's nice about this is that it allows you to mix sort of plain text descriptions with code, and then also any figure or statistical output. So this is really nice, like when you're building up a report, like if you want to show to your boss or whatever, or just making notes for yourself. Instead of, like for a long time, I would just kind of try to save up a bunch of output and then kind of copy and paste it into a Word document, but then I would kind of lose track of why did I do this, or I would lose steps along the way. And this kind of, because you keep all of the code and the output in the same place, it ends up, I think, it makes things a lot easier on yourself when you're trying to repeat analyses or just trying to understand why you were doing things. But so ggplot. So the way that Markdown works is that so you can run all of these chunks of R code by running here on the right, and so it's basically sourcing it down to the console, so as if I were sort of writing all of that code on the bottom. And so I'm just loading all of these libraries. But so ggplot's the main plotting library. So let's begin by plotting. So glimpse is a good command to sort of understand. Let's see. So run is a way to sort of run a single line of code instead of running the entire chunk. So a chunk would be everything in gray, so all 3 lines of code. But here, run will only run the sort of highlighted line. So glimpse will, so it's kind of like head. So it'll give you a summary of the data frame. So basically, what is this data set of miles per gallon? So this is a data set of different cars and their efficiencies on the city and highways. And so the way that ggplot works is that it sort of fundamentally wants you to divide the plotting between, so it wants you to do the aesthetics of, so it wants you to define, like, what are the x and y variables separately from what are the shapes going to look like. So when you're doing this, so when you're doing ggplots, there's always going to be this first call where you're just sort of defining, okay, here's the data, and then this aesthetic call where you're defining, okay, what are the x and y variables, and then maybe color, or something like that. And then secondary calls that are actually what are the shapes. So that's kind of the basic, that's what all of the ggplot calls end up looking like. So, so if we run this, so that's kind of the simplest plot that you can do, where you're plotting the displacement, so the engine size against city mileage. And then, so what's nice about ggplot is that, so if we just add one extra little color equal drive, so now we've added a third variable. So, and so now we can sort of run this. And so now it's highlighting, so so now we know that there's actually sort of three fundamentally different types of cars being plotted here. So these sort of very efficient wussy cars that are front wheel drive, and then here you have the rear wheel drive kind of muscle cars, and then sort of in the middle you have the four-wheel drives. So what's really nice about ggplot is that, like, you get a really nice looking plot with, you know, this doesn't take much to type at all, once you know what to give it. So faceting is another sort of really important thing that comes up in ggplot. So faceting is another way of subdividing the data. So this is another way of, if you have sort of a third variable, and you sort of want to understand the relationship between, so if you have two primary variables and you want to understand how that relationship is affected by a third variable. So here, sort of the primary relationship we're interested in is sort of price. So this is diamonds, and we're sort of looking at the relationship between carat and price. But then we're looking at, so it's this facet called a color. And so we're seeing how that relationship between carat and price is affected by different colors. And so basically it's subdividing the data by these different color groups. One of the other things that I'll sort of mention really briefly is that, so when you're using color groups, then so be mindful that there's a substantial amount of the population that's colorblind, and often people are going to try to print out your figures in black and white, and so that might end up losing any of the information, and so let's see.
We have one attendee that asked, "Where's the data being pulled from?"
Sorry, say again.
Where's the data being pulled from?
So the data. So these are all data sets that are sort of built in with these libraries. So yeah, so it's basically associated with dplyr and ggplot2. So yeah, so you can just start messing around with those data sets immediately. let's see. Yeah. So this is just an example of this relationship between the caret and price again, and then here it is with a, so this is the Viridis color map, and so this is something that is by default will be, so it's easier for colorblind people to see, and will if you print it out in black and white, it's easy to visualize. So just sort of keep that in mind. So kind of the next thing that I'll talk about. So dplyr is a, so when you're when you are trying to manipulate your data before visualizing it, dplyr is a really useful package for that. And so there are kind of 5 fundamental verbs about sort of how you can modify data sets. And so what's nice about this is that it's kind of optimized with C code, so it ends up being much faster than trying to do these transformations with the base code. So the first is filter. So okay, so this is the, so this is an interesting data set. So this is the flights data set. So this is a bunch of flights from 2013, and basically whether or not they left on time or not. And so filter is a way that, so here we can just say, okay, we only want to take observations where there was some departure delay. And so in the original data set, there were 330,000 observations, and now if we look at this again, and now there's 130,000. So the next verb, so select, so you'll notice that there's sort of 19 variables in this data set, but often you don't really care about most of these when you're so if you're given some data set, often you don't care about most of these. So when I was messing around with this data, I was like, I don't care about year, month, day, any of that. And so so select, you can just filter out, okay, what are the columns that you actually want? And that makes it easier for kind of downstream analyses. And so now, if we look at that, so now we just have 5 variables that we're working with. So the next verb, so mutate, so this is a way to create new columns where you're sort of transforming so columns based off some combination. So here we can create 2 new columns, so based off sort of the gain, sort of the arrival minus the departure delay or the speed. And yeah, and so now, so you see we have 2 new columns. And then, so arrange is, and then arrange is another, arrange is just a simple way to sort by different columns. So this will sort it by the departure delay or by descending values. And then, so summarize will collapse. So summarize will give you summaries of the data as a single row, and where this really comes into its real role is when you group the data with group by, and I'll sort of show that off in a little bit. But so as a sort of basic example, if you're sort of just using the whole data, then you can just calculate the average departure delay. And then, so this pipe, as like I had mentioned in the slides, so so pipes let you chain together like several of these actions together, and that lets you it lets you perform actions in a more logical order. So here we start out with the raw data, flights, and then we say, okay, let's filter it, and then we can select for just the columns that we want, and then we'll create a new column with mutate. And so that follows in a left to right order. Okay, so the equivalent code, if we don't use pipe, is this. So basically you have to go inside out. So you have to do this filter, then select, then mutate. And it's just, it's much harder to construct that and understand it, especially for somebody else to kind of come along and understand what you were doing. So pipes, like it takes a while to get used to, but it's a really powerful. Yeah, it's definitely worth learning how to use it, and then sort of regardless of language, a lot of data science, it's a functional programming tool. Sort of Sorry?
Can I ask you a question real quickly? So
Sure.
with that line of code that you just went over, so what is? Can you state like what that actually is saying in layman's terms? So, in other words, what I'm kind of wondering is if your employer or whomever is asking for a certain set of data they want to have displayed, how you go about kind of defining that in your code. And so I'm wondering, how would somebody have said, whatever this is saying, can you just kind of make it plain and say what this is actually pulling in? Layman's terms or whatever.
Right. So this is what this command is doing is selecting for flights that have had some delay, and then it's calculating whether or not when they did leave with a departure delay, were they able to make up that any time in the air. So that's what the mutate, that gain. So it's the arrival delay minus the departure delay.
Okay.
So that's does that make sense?
Yeah. So I think so it absolutely does. I think when this particular piece of code, what I was wondering it was about the mutate and how that actually is working, but I think you have explained it perfectly.
Uh-huh. Yeah, and so like so this was, so chaining, this was just kind of showing that without plotting, but then you can also just feed all of those, you can feed all of that directly into a ggplot call as well. Oh, wait. Yeah, and so this is basically just showing, okay, what is the variation in departure delays by carrier code. So you see there's some, yeah, some are, so whatever a carrier is 00 are pretty consistent about not, they rarely have much of a delay, but then some of these carriers have very, you know, they have flights that were stuck on the ground for hours. Group by, I sort of explained this. So group by is a way to, so this is a way of, so if you use that summarize, or really any of the functions, it lets you subset the data by a different variable. So in this case, so what this is saying is, okay, so take the data and then subset it by tail number. So what this is going to do is make all of the subsequent operations sort of organized around individual planes. And so it's going to sort of average over, so there are planes that sort of took a bunch of different flights, and then it's going to average over those flights. And so then when this runs, so all of these points are averaged flight data per airplane. So that's kind of that's again getting a little bit advanced, but I kind of wanted to mention it at least. So that kind of covers dplyr. So it's a really good tool of kind of that those kind of 5 core verbs will end up being the main ways that you kind of shape your data. So like that it's a pretty useful tool. So if you use mapping data, ggmap is a really good library. And then so I'll just kind of show. So and again, so ggmap is, so it's using the same, so it's using the same basic function calls of ggplot, where you're sort of defining the map, and then you're using these geometries. So it ends up looking very similar. And then this is ghost sightings in Kentucky, but so the maps look very nice. Let's see, and then the sort of final thing that kind of wanted to talk about is some code that I've been kind of developing on the side, and so this is some code for collecting and analyzing Twitter data. And so this has mostly been around some scientific conferences, but so really any conference or any hashtag use. And so and yeah, so you can I sort of have a GitHub repository set up for this, but let's see. Do I have this set up? And so once you've kind of collected the Twitter data, which I've just kind of read in a CSV file here. This is from a conference from a couple months ago. But so one of the kind of common things people want to do is, so you just want to visualize sort of what are the topics that people are talking about at a conference. And you can visualize that with a word cloud. And so this was a Python scientific conference, so you see things related to that data. Anyway, so one of the other things that people often like about this is sort of who are the sort of most active users that are sort of tweeting most actively around a hashtag, and this is the code to sort of visualize that, and so this just gives you a bar graph of sort of which accounts were most active for that hashtag. And so this next thing, so this is Twitter's sentiment. So sentiment analysis is a way to measure how much positive or negative emotion is given in a text. And so what that means, so like I hate you would be something that would be scored negative, or whereas like I'm so happy right now would be something that would be scored positively. And so this is just a very simple way to kind of track how, like, what is the basic emotion of the conference through time. And so what's interesting about it is that you can often kind of map this to events that are going on at the conferences, or so in this case this is the end of the conference, so everyone, it was sort of the last talk, and then everyone sort of went out for beers, and then this sort of, and then everybody left.
So how is it actually able to like translate emotion?
So it counts up. So for every tweet, it basically just counts. So there's a dictionary where, like, previous research has identified, okay, happy is a positive word, and sad is a negative word. And then it just looks for how many times do those words come up in tweets. And then it just kind of scores the sort of total number of times. Yeah, so the sum of positive minus negative words in a tweet. So it's a very simple way of measuring sentiment. Like there are more sophisticated ways of measuring it, but like in this case, because you're doing it over a bunch of different people that are talking about it, it still seems to capture these larger events.
Okay, thank you.
So then I guess the last thing that I was going to show was a way to visualize the Twitter tweet retweet network. So basically, this is like who is talking to who in these contact networks. So who follows who is not very informative because there are so many bot accounts, but sort of the retweet network information turns out to actually be informative. So so you can, when you visualize this gives you a sense of let's see. So this first code is sort of generating that network, and then the second code is actually visualizing it. And so, fortunately, yeah. So here, so the lines are basically are drawn between accounts that were actually talking to one another, and then the size of the dot is basically how active in the hashtag it was, and so you can see like the SciPy conference account. So it was kind of it's kind of centrally located in this graph. So everybody was kind of talking to it, and it was retweeting everybody else. But then there are these other three accounts were really important, where most of the other accounts were talking to them as well. So that's kind of, so I guess the way that I tend to use these or try to understand these is that when I'm looking at these, I usually pick out a few of these accounts to follow because they usually have interesting stuff to say. And that's really about it. And then, you know, I sort of have more descriptions for each of this, for each of these code chunks, but that's all I really had to go over for now.
Well, I have a question. So how do you get RStudio?
Yeah, so RStudio is, let's see. So if you go to, so it's just RStudio, and then, so they make a bunch of different products, but So they have a free license in pretty much yeah. So for almost everybody's purposes, you can just um, download and use this for free. Like I think yeah, there are some rare instances where you might need to pay for a production license, but everybody. So they have a Windows Mac, and then Ubuntu and Fedora. Uh,
Okay.
uh, so
Okay. Well, thank you so much.
all right. Okay. Thank you for your time.
All right, thanks. Have a good one.
All right.
Thank you so much. Did you get everything in? All the questions answered, Thomas?
I think so.
Awesome. Are you going to stay and enjoy the rest of the conference?
Yes, that's my plan.
Yay. Well, I enjoyed you. Thank you so much for your time and your presentation.
Uh-huh.
We look forward to seeing you in the other sessions.
Great. Thank you.